1 over b to the exponent x and b to the exponent negative x. So if you look at b to the exponent x, you're essentially looking at bases for the function that are greater than 1. And for 1 over b to the exponent x, we're looking at functions where the base is between 0 and 1. And then b to the exponent negative x, it doesn't really matter what the base is. But what I want you to notice is that in this case you have a negative exponent. And if you think back to what happens when you have a negative exponent, that's the same as writing the reciprocal of the base to a positive exponent. That's one thing to remember. The other way of thinking about this last function is based on your transformations that we know. Okay? So any transformation that happens where the x is a horizontal transformation. We also know that when there's a negative in front of the x, so negative coefficient in front of the x, that indicates a horizontal reflection along the y-axis. So a few things for you to think about as we go through the last part of the investigation. So if you notice the graph, so I have y equals 3 to the exponent x. That's an increasing function just like we noticed before. Then we have y equals 1/3 to the exponent x. Because the base is between 0 and 1, you'll notice that there's a decreasing function here. It overlaps with the green function, which is why you might not be able to see the red or the pink distinctly. And then the last function is y equals 3 to exponent negative x. And this one also seems to be a decreasing function. And you'll notice that this function, the green one, y equals 3 to exponent negative x, looks exactly the same as y equals 1/3 to the exponent x. So, question number 3. So after graphing using our table of values, question number 3 says, describe the relationship between y equals b to exponent x and y equals 1 over b to exponent x. So if we compare y equals 3 to exponent x to y equals 1 over 3 to exponent x, you'll notice that they're very similar, but their behavior is opposite. Okay? So what you'll notice is that they're both exponential functions. However, one of them increases, whereas the other one decreases. So their behavior is opposite. One's an increasing function, and the other one is a decreasing function. Okay? You'll also notice that the graphs are horizontal reflections of each other along the y-axis. So if I use the y-axis as a line of reflection, you'll notice that each of the points reflect off of each other along the y-axis. So they're mirror images of each other along the y-axis. So for example, here I have a point at 1 and 3. Over here I have a point at -1 and 3. Here I have a point at 2 and 8. Here I have a point at -2 and 8. So the x values are opposite in sign, and so that's why it's called a horizontal reflection along the y-axis. Now if we look at the next question, it says describe the relationship between y equals b to exponent x and y equals b to exponent negative x. So the blue graph is y equals 3 to exponent x, and the green graph is y equals 3 to exponent negative x. And what you'll notice is these are also horizontal reflections of each other along the y-axis. The reason for that is because you're going from y equals 3 to exponent x to y equals 3 to exponent negative x. That negative in the exponent indicates a horizontal reflection, and you can see that clearly between the green graph and the blue graph. Okay, the last question says describe the relationship between y equals b to exponent negative x and y equals 1 over b to exponent x. So we want to know the relationship between the green graph, which is y equals 3 to exponent negative x, and the pink or red graph, which is y equals 1/3 to exponent x. And you can see that they're both identical. They're the exact same graph. Why does that happen? Let's look at the equations algebraically. So if I compare y equals 3 to the exponent negative x to the graph of y equals 1/3 x, what you'll notice is I can actually rewrite this equation in a similar way as y equals 1/3 to the exponent x. Now, again, remember your negative exponent rules. And so if I have a negative exponent, I can write the reciprocal of the base, which is 1/3, to a positive exponent. So 1/3 to the exponent x, well, that looks exactly like the pink graph that I had before. So a horizontal reflection looks very similar to a function with a base that's less than 1. Okay? So in this case, the graphs are identical. A negative exponent can be rewritten as a reciprocal of the base to a positive exponent.